Hi children, this is your Kalpana teacher. Children, in the previous session, you learnt about the types of waves. In this session, you are going to learn about characteristics of the sound wave. Four quantities play an important role in describing the nature of a wave. These quantities are its wavelength, amplitude, frequency, and wave speed. They are called the characteristics of the wave. Let us learn about these characteristics in the context of the sound wave. Now, let us consider a sound wave produced by a source such as tuning fork. The pressure of air is proportional to density at a given temperature. The plot of density versus position will also have same shape. It can be seen from the graph that in portions like PQ the density is more than the normal density. It represents compression. In portions like QR the density is less than the normal. It represents a rarefaction. Thus, the compressions are the regions where density as well as pressure is high. The rarefactions are the regions where the density as well as pressure is low. In above density versus position graph, the peak of the graph is called crest and valley of the graph is called trough. Now, let us understand about wavelength. The wavelength means the distance is called the wavelength of the wave. It is denoted by a Greek letter lambda. We can define the wavelength as the distance between two consecutive compressions or two consecutive rarefactions is called the wavelength of a sound wave. Remember children, it is denoted by the letter lambda. We can read as lambda. Being a length, the wavelength is measured in meters. So SI units of wavelength is meters. Now we are going to discuss about amplitude. Amplitude of a sound wave in air can be described in terms of the density of air or pressure of air or the displacement of the layers of air. You know that when sound travels in air, the layers of air move to and fro. Is it right? Causing compressions and rarefactions. So as a result, the density and pressure of air at a place varies. Its value increases from the normal to reach a maximum and then reduces to minimum. The amplitude of density of medium is the maximum variation in the density when sound wave passes through it. Similarly, we can define amplitude of pressure and displacement of the particle of a medium when sound travels through it. So, thus, the maximum disturbance of particles in the medium on either side of mean position is called amplitude of wave. Understand children? Thus the maximum disturbance of particles in the medium on either side of mean position is called amplitude of the wave. It is usually represented by a letter A. The units of amplitude depend on which terms the amplitude is being described. Because if sound wave is moving through air, we can describe amplitude in terms of density and pressure. If sound wave is moving in solids, we describe the amplitude in terms of displacement of particles from their mean position. So, observe the units in this table children. Now we can discuss about time period and frequency. We know that when sound is propagating through a medium, the density of medium oscillates between a maximum value and minimum value. The time taken to complete one oscillation of the density of the medium is called the time period of the sound wave. It is represented by the symbol T. Its SI unit is second. Frequency is a quantity that is closely related to time period. We can define that the frequency of sound wave as follows. The number of oscillations of the density of the medium at a place per unit time is called the frequency of the sound wave. We usually use Greek letter nu. We can read as nu. It is denoted this symbol. Now the relation between frequency and time period we can observe. Let us find the relation between frequency and time period. Let the time taken for new oscillations we take as 1 second. The time taken for one oscillation is 1 by new seconds. But the time taken for one oscillation is called time period, and the number of oscillations per second is called the frequency. Hence, frequency and time period are related as T is equal to 1 by nu, or nu is equal to 1 by T. The SI unit of frequency is Hertz. It is named after Heinrich Rudolph. So this problem, find the time period of the wave whose frequency is 500 Hz. Here the frequency is given 500 Hz. We can find the time period. What is the formula for time period? T is equal to 1 by nu. We know that T is equal to 1 by nu. So we substitute the frequency value. Nu value is 500 seconds. So if we substitute and calculate, we get the time period is equals to 0.002 seconds. Children, now we are going to discuss about speed of sound wave. The distance by which a point on the wave, such as compression or rarefaction, travels in unit time is called speed of sound wave. Let the distance travelled by a wave in t seconds is lambda meters. The distance travelled by a wave in 1 second is lambda by t meters. Thus, by definition, the speed of sound wave v is equal to lambda by t. We know that the frequency nu equals to 1 by t. V is equal to lambda by t we can take as first equation, and nu is equal to 1 by t we can take as second equation. From these two equations we get V is equal to nu lambda. Means speed of a sound wave is equal to frequency into wavelength. The speed of a sound wave depends on the properties such as the temperature and the nature of the medium in which it is traveling. But the speed of sound remains almost the same for all frequencies in a given medium under the same physical conditions. Now we are going to do one example problem. Here observe this problem, children. In a certain gas, a source produces 40,000 compression and 40,000 rarefaction pulses in 1 second. When the second compression pulse is produced, the first is 1 centimeter away from the source. Now we should calculate the wave speed. Here what are given? Once observe this problem, children. In this problem, we know the frequency is equal to the number of compressions or rarefaction pulses travelled per second is called frequency. So here the frequency is given as 40,000 Hz. The wavelength is given as 1 centimeter. Wavelength means you know the distance between the two consecutive compressions or rarefactions. So lambda is given as 1 centimeter. If we substitute this nu value and lambda value in the equation V is equal to nu lambda, we get the 40,000 into 1 centimeter. We get V value is 40,000 centimeters per second. Or we can write this 400 meter per second. Children, for better understand, you can go through this video also.
The wave. What about the size of the wave? Wave goes up in certain amount and goes down certain amount. Maximum distance from wave's normal position is called amplitude of wave. It can be upwards or downwards. Amplitude indicates the amount of energy transferred in the wave. Larger the amplitude, more the energy transfer. Symbol for amplitude is A. It is the distance from rest position of the wave particle. In this simulation, Smaller drops result in small amplitude. Large drops result in large amplitude. We can switch view and see how it looks from the top. This is called crest and this is called trough. Crest and trough are of same size. We can express these concepts with voice as well.
Let's hear sine, low pitch, low amplitude. Sa. Let's hear sine, low pitch, high amplitude. Sa. Let's hear sine, high pitch, low amplitude. Sa. Let's hear sine, high pitch, high amplitude. Sa.
We discussed about period of the wave by looking at the position of just one particle. In order to find out spacing between two crests and two troughs, we need to consider a series of particles involved in a wave. Instead of time on the x-axis, we will use the distance from the source on the x-axis. This graph is vertical position of the particle on y-axis and its position from the source along the x-axis. This distance between two crests is called wavelength of the wave. We can generalize this and say that wavelength is the distance between the repetitions of the shape of the wave. Distance is parallel to the direction of wave travel. Wavelength is denoted by letter lambda. You must have seen fireworks during festive season. Have you noticed the sound when fireworks is high in the sky? Is it immediate or you hear it after some time? We normally hear sound after we have seen the flash of the exciting fireworks. It is because the speed of sound wave is much slower than that of the light wave. Speed of wave is different in different mediums. The relationship between speed of sound, frequency, wavelength can be stated as speed equal to frequency multiplied by wavelength. The frequency of the wave is the same as that of source. Speed of sound is different when it changes medium, but frequency is pretty much the same. From the equation, we can say that when speed changes, wavelength must change as frequency is constant. Summary. We discussed about important characteristics of wave. This distance between two crests is called wavelength of the wave. Speed of wave is different in different mediums. The relationship between speed of sound and frequency wavelength can be stated as speed is equal to frequency multiplied by wavelength. Amplitude indicates the amount of energy transferred in the wave. Larger the amplitude, more the energy transfer. Symbol for amplitude is A.
Children, I think you understand very well about the characteristics of the sound wave. Four quantities, the characteristics of sound waves: wavelength, amplitude, frequency and wave speed. You understand very well, I think. Thank you, children.